Okay, so I'm recording today the solutions to the extra review problems that I assigned last Thursday. We're going to start with the ones that came from the chapter test on page 360. All three of these, 13, 14, and 15, are referring to the diagram I have drawn here. And so the question was asking, does the given information prove that the quadrilateral ABCD is a parallelogram, and then to explain why. So number 13, we're given that AB is congruent to DC, and we're also given that AB is parallel to DC. So this one, the answer is yes, because theorem 6.8 tells us that if one pair of opposite sides of a quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. Okay, so that one's a yes. Let's look at the next one. On number 14, AB is congruent to DC, again, and also BC is congruent to AD. So is there enough information there to show that that's a parallelogram? The answer is yes on this one also. So this one would be theorem 6.5. I guess I should have said yes here and yes here. All right, so theorem 6.5 says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And finally, number 15, we're given that angle DAB, that's here, is congruent to angle BCD, here, and angle ABC, here, is congruent to angle CDA, there. So what we're given is that both pairs of opposite angles are congruent. So this is enough information to say that that quadrilateral is a parallelogram, and that is given in theorem 6.6. Okay. All right, so now going to the next problem from the chapter test, number 17. Determine the values of the variables for which ABCD is a parallelogram. So what we have to do is think about what we were just doing. In order for ABCD to be a parallelogram, both pairs of opposite sides have to be congruent. So I need 7x minus 1 to equal 6x plus y. Oops. And I need 7x minus 2 to be equal to 5x plus 2. Change colors so it's easier to see. Okay, so sometimes we were given two equations that both had two variables in them, and we needed to use the system of linear equations to solve it. But here we have this equation is they both have x's on each side. So I can solve this one, and I will get 2x equals 4, and that means x equals 2. Then I can use that into my other equation to get value for y. So I'll have 7 times 2 minus 1 equals 6 times 2 plus y. So 14 minus 1 will be 13 is equal to 12 plus y. I subtract 12 and I get y equals 1. Now they didn't ask for the length of the sides, they just wanted the values of the variables, so we don't have to go any further than that. Okay, in both 18 and 19, the problems are both asking to find the measures of angles 1 and angle 2. So we have to take into account what figure we're looking at. In number 18, we're looking at a kite. And so some of the things we know about kites are that their adjacent sides are congruent, and that's marked already. And we also know that the diagonals of a kite are perpendicular. So that's one of the things that we're going to use. So that helps us get angle 1. If the diagonal is perpendicular, then I know that the measure of angle 1 is equal to 90. Okay. And then I'm looking for the measure of angle 2. So since angle 1 is 90, so are all the angles around this intersection of diagonals, which helps me be able to figure out what some of these angles are. So if I know that that's 90, if I'm looking at this triangle, this triangle is also congruent to the one that has angle 2 in it. But I can use the triangle that I've shaded in. They told me that 60 degrees was one of the angles, so I can figure out that the other angle that's missing here is 30. And if I know that's 30, then angle 2 is the same thing because those two triangles are congruent. Okay, and those are the only angles we had to find. All right, we move it on to number 19. Number 19 is an isosceles trapezoid. We have one pair of parallel sides and the legs are congruent. I'm given that an angle, one of the base angles is 50. And what I know about trapezoids is that, first of all, angle 1 and the one that's marked 50 have to be the same because each pair of base angles has to be congruent. So I know that measure of angle 1 equals 50 degrees. And I also know that same side angles in a isosceles trapezoid are supplementary. So I can say the measure of angle 2 plus 50 degrees equals 180, which means I'll just subtract 180 minus 50 and get 130. And that has to be equal to the measure of angle 2. Okay. Okay, this one I gave myself a little more room for. Here we have to graph. This is well, we're moving to the chapter for review questions now. So this is number 11 from page 357. I'm given the coordinates for this quadrilateral, and I'm supposed to graph it and then come up with the most precise name for it. So I can't draw straight lines very well. All right, so let's put these on here. N is -1, 2. M is 3, 4. K is 5, 0. And L is 1, -2. So once I connect these vertices, I can make a guess of what it looks like. It looks to me like this is a parallelogram at least, and maybe a rhombus. So since I'm thinking that it may be a rhombus, I'm going to check the lengths of the sides. So I'm going to find NM, and I'm using the distance formula to do that. So that's going to be 3 minus a -1 squared plus 4 minus 2 squared. So that's going to give me 4 squared is 16 plus 2 squared is 4. So I'm going to get the square root of 20. Now I could simplify that, but I don't need to. I'm just going to compare it to the length of LK. So I want to see if NM is congruent to LK. That's my question. I'll also check MK and LN as well. All right, so LK be 1 minus 5 squared plus negative 2 minus 0 squared. Alright, that's going to end up being negative 4 squared, which is 16, plus negative 2 squared, which is 4. So for that one, I also get the square root of 20. So I know that NM and LK are the same. I'm going to go ahead and check the other two sides. KM is going to be 5 minus 3 squared plus 0 minus 4 squared. That's going to give me 2 squared, which is 4, plus negative 4 squared, which is 16. So again, I get square root of 20. Okay, and then the last side that we haven't checked is NL. That's going to be 1 minus a negative 1 squared plus negative 2 minus 2 squared. So that's going to give me a 1 plus 1 is 2 squared, which is 4, plus negative 4 squared, which is 16. So that's negative, I'm sorry, 16, that's a square root of 20. So they all end up being the same length. All right, that tells me for sure that it's a rhombus. It also tells me that it's a parallelogram because both pairs of opposite sides are congruent. The only other thing that it could be that would be a little more precise would be a square. So what I need to do is check at least one pair of angles, the slopes of two sides, so that I can find out if they're perpendicular or not. So I'm just going to pick NM and MK. I want to do adjacent sides so I can see what their slopes are. My pen is not writing right. All right, so for NM, the slope would be 4 minus 2 on top over 3 minus a negative 1 on the bottom. So I'm going to get 2 on top over 3 plus 1, so over 4, that's 1/2. Now I want to check the slope of MK. I don't know why this pen doesn't work sometimes. Okay, so MK, the slope would be 0 minus 4 over 5 minus 3. So I'm going to get negative 4 over 2, which is going to be a negative 2. So because these are negative reciprocals of each other, I know that they're perpendicular. And if this angle is perpendicular and I already know it's a parallelogram, that means all the opposite angle has to be congruent and the same side have to be supplementary. It ends up that we know that each of these are 90-degree angles. So the most precise name for this one is a square. So when you do a problem like this on the test, you need to graph it and look at it and see what you think it is, and then figure out what you would need to show to prove that's what it was. And that's what you're going to use to give me your answer with your explanation. All right, now these next two problems, we need to find the value of variables and the lengths of the sides. So how we do this is going to depend on what the figure is. So the first one we're looking at is an isosceles trapezoid. So I I need to find the value of x first. The way that I'm going to do that is to compare the two sides that are congruent. So I'm going to do 2x minus 7 equals x plus 1. We don't know anything about how the lengths of A, B, and CD compare to each other. We only can do the two legs that are marked as congruent. So that's going to give me x equals 8. And then I can find the lengths of the sides by just plugging that back in. So for AB, it's going to be 2 times 8 is 16, minus 2 is 14. For BC, it will be 9. For CD, it's going to be 7. And for AD, it will be 2 times 8 is 16, minus 7 is 9. So it should be the same as BC, and it is. Okay, moving to the next figure, this is the one that's given as a kite because I know that both adjacent sides are congruent. So I'm just going to compare those ones that are congruent to each other. So I'll do m plus 3 equals 3m minus 5. All right, that's going to give me 2m equals 8, so m equals 4. And then I can use that as I find what t is. So my other pair of congruent sides give me m plus 2t equals t plus 9. And so I need to plug my n in. That'll be 4 plus 2t equals t plus 9. That's going to give me t equals 9 minus 4, which is 5. Now that's part of the answer, but they wanted the lengths of the sides, so I have to go back and plug those in. So KL will be 4 plus 3, which is 7. KN will be 3 times 4, which is 12, minus 5, which is 7. LM equals M, which is 4 plus 2 times 5, so 14. And NM is 5 plus 9, which is 14. Okay, so here I'm supposed to find the value of the variables for which ABCD must be a parallelogram. That means we follow the rules per parallelogram just to make sure it's true. We get the variables based on that. So I know that if this is a parallelogram, opposite angles would have to be congruent. So 4x would have to equal 4y plus 4. And 3y minus 20 would have to equal 2x plus 6. Now this is one of the ones that's a little more complicated to solve. This is a system of equations in two variables. The best thing to do is to find the one that would be easiest to solve for a specific variable and then do substitution. So I'm going to use this top equation, divide everything by 4, and I'll get x equals y plus 1. Now I can take y plus 1 and put it in for x in my other equation. Change color so it's more visible. So I'll have 3y minus 20 equals 2 times y plus 1 plus 6. So I'm just substituting in y plus 1 where there's an x. And then I'll solve this. So 3y minus 20 equals 2y plus 2 plus 6. So 2y plus 8 equals 3y minus 20. This is going to give me y equals 28. Oops. I don't know why I put a 0 on the end of that. Alright, so that's my y. My x will be 28 plus 1, which is 29. Okay. Now to the next problem, we don't have angles, we have diagonals. And remember that in in our theorems, we knew that for parallelograms that they bisect each other. And so I know this is I want this to be a parallelogram, so I want them to bisect each other, which means each piece of the different diagonals are congruent. So I'm going to have 4x minus 2 equals 3y minus 1. And I'm going to have 3x equals 3y minus 3. And that's my system of equations. So this is very much like the one we just did. This time this bottom equation is the easiest to solve. I divide everything by 3 and I get x equals y minus 1. Now I'm going to take that y minus 1 and I'm going to plug it into the other equation for x. So 4 times y minus 1. Minus, so I'm using this one. That's my 4 times x, and then I have to put the minus 2 equals 3y minus 1. So distribute 4y minus 4 minus 2 equals 3y minus 1. That's going to give me 4y minus 6 equals 3y minus 1. So I'm going to have y equals 5. And then x will be 5 minus 1, which is 4.